Scientists and engineers were racing toward the same deadline. 90 days to put a satellite into orbit.
The Army is requesting the Jet Propulsion Laboratory to provide the following programs. First, the additional high-speed propulsion systems required. Second, the orbiting missile or satellite. And third, the necessary instrumentation to record and transmit the scientific data assigned to this experiment.
This assembly, which is the actual payload for the satellite, contains both transmitters, necessary circuits for the impact microphone, which will detect the collisions with meteorite particles, and a Geiger counter to measure cosmic ray intensity.
At Cape Canaveral, Florida, the Army's Jupiter-C rocket is ready for America's second attempt to launch a space satellite. The hours-long countdown approaches zero, a moment of enormous tension, for every missile launching is still an experiment. Any one of tens of thousands of things can go wrong, with catastrophic results. But all that to assure perfection has been done. The moment is at hand. The countdown reaches zero. Some 3 minutes later, Explorer is in orbit, broadcasting to the world its coded scientific data. This close-up of the United States edition of Sputnik was made at a press conference with leaders of the scientific teams, Dr. Werner von Braun, Dr. James Van Allen, and Dr. William Pickering, a three-way collaboration between private industry, academic science, and the military. Cosmic ray intensity, meteor impact, solar radiation. These are the dry facts that will help carry man ever farther into the age of space.
The man-made satellite Explorer was injected into orbit at 22:48 hours on 31 January 1958 as part of the United States contribution to the International Geophysical Year program. This is the story of that historic launching, which will serve as a forerunner for free man's further conquest of space. The United States Army's Jupiter-C stands poised on its launching pad at Cape Canaveral, a needle-nosed giant anxious to split the heavens and bear aloft a satellite dubbed Explorer, containing some 18 pounds of scientific instrumentation. For the missile scientists of Huntsville, Alabama, Ames, Iowa, and Pasadena, California, Von Braun of Army Ballistic Missile Agency, Van Allen of Iowa State, and Pickering of Caltech, for General Medeiros and all the Army men behind the missiles, for the American people, from the man in the street to the man in the White House, this is a night of hope, a night that looks into the future. Hours ago, the countdown began. X-6, and still counting. X-5, and still counting. Tonight is the climax of months of preparation, the result of Army teamwork, uniting the efforts of the Army Ballistic Missile Agency and the Jet Propulsion Laboratory of the California Institute of Technology, whose scientists are seen here conferring during a preliminary phase of the project. The Caltech team was responsible for the assembly of Explorer, for providing the two radio transmitters incorporated into the satellite. And they supplied the upper stage's high-speed assembly in a design that radically departed from previously conceived satellite launchers. A spin balance test puts the Explorer satellite and its final stage rocket through their paces. Along with this rotation launcher, a bucket of solid fuel rockets developed by the Caltech Jet Propulsion Laboratory. At firing time, the bucket will rotate in this manner, spin stabilizing the upper stages of Jupiter C